All right, this is Unit 2, Lesson 1 on vertex form of a quadratic equation. So our lesson essential question is, how does the equation of a quadratic function in vertex form highlight key features of the function's graph? So basically, we're going to use this form in order to tell us things about a particular quadratic function graph. So at the end of this lesson, you'll be able to identify key features of quadratic functions. All right, so the key concept, representations of quadratic functions. A function is a quadratic function if its equation can be written in the form f of x equals ax squared plus bx plus c, where a cannot be 0. All quadratic functions are transformations of the parent function defined by f of x equals x squared. So basically, I can take this x squared and I can stretch it, I can move it left, right, up, down. Okay, I can flip it, whatever that case may be. The graph of a quadratic function is called a parabola. Okay? The vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k, where hk is the vertex of the parabola. So in this case, this is x squared. My vertex is 0, 0. So when I write this, I would have a times x minus 0 squared plus 0. Okay. It's useful because it highlights the vertex of the graph of the quadratic function. All right, so example number 1. Example 1 says to transform a quadratic function. So how are transformations of the graph f of x equals x squared related to an equation representing another quadratic function, g of x equals negative 1/2 x plus 2 squared? So remember from the first unit where this told me, the inside told me if it was moving left or right. Okay. And this told me whether it was being stretched or shrunk, as well as my flip for reflection. So the vertex form shows 3 different ways in which the graph of the function f of x equals x squared may be transformed: a, h, and k. Okay. So I have h here plus 2. As I can see, it's a minus h here. So this tells me it's a negative, which means I had to move 2 units to the left. The value of a determines the direction of the parabola opens and whether the graph is stretched or compressed. So it went from being positive to negative. So it flipped from pointing upwards to pointing down, to opening down. Okay. The value of h determines the horizontal transformation, so it moves left or right, and k determines the vertical translation. The equation shows that the graph is to be translated 2 units left, will open downward, and will be vertically compressed. So if you look at B, again, I'm going x squared related to an equation representing another quadratic function, j of x equals 2 times the quantity x minus 1 squared minus 3. So again, I'm moving right 1 unit, I move down 3 units, and I'm vertically stretched, but I'm still opening upward. Okay, so a is greater than 0, the parabola opens upward. When a is less than 0, the parabola opens downward. When the absolute value of a is greater than 1, the graph is stretched. And when it's between 0, less than the absolute value of a is less than 1, the graph is compressed. So 2, absolute value of 2 is 2. That's greater than 1, so the graph stretched 2. So to see these effects easily, use the same axis or units for all graphs. So basically, I've graphed x squared, and then I graphed the 2 times the quantity x minus 1 squared minus 3. All right, so let's try it. So describe the transformation of the parent function f of x equals x squared, then graph the function. So my graph is g of x equals negative x plus 2 squared. So the plus 2 tells me that I'm moving horizontally, okay, either left or right. Positive, so I'm going to move left. So I'm moving left 2 units, left 2 units. And the negative tells me that I'm flipping it. So it's reflected across the x-axis, which means it opens downward. So this is moving 2 units to the left, 1, 2. And I'm moving it down. So the equation shows the graph is translated 2 units to the left and will open downwards, which we did. Okay, then I have described the transformations of the parent graph f of x equals x squared, then graph the function g of x equals x minus 1 squared plus 2. So the minus 1 tells me move 1 unit to the right, and the plus 2 tells me to move 2 units up. So 1 to the right, 2 up. Nothing else. I don't vertically compress or shift or anything like that because there's nothing out in front. All right, example 2, determine key features of a quadratic function. What are the key features of the quadratic function f of x equals 2 times the quantity x minus 3 squared plus 4? So looking at this, I can tell that I moved 3 units to the right, 4 units up, and I have stretched vertically 2. So 2 indicates that the graph opens upward and is vertically stretched because it's positive. If it was negative, it would open downwards. The range is y is greater than or equal to 4. Okay. There are no restrictions on the value of x, so the domain is all real numbers. The axis of symmetry is the line x equals h or x equals 3. Okay. So at this point, if I were to fold it in half right at that point, the lines would overlap each other and meet. Okay, so they're basically, that's the axis of symmetry. So it's the same on the left side as it would be on the right side of the equation or the graph. The vertex is the ordered pair HK. So remember, if this is minus, that's a positive. If it's plus, it would be a negative. I know it's a little weird to think about it flips for this. If you were to plug it back in, so if you were to say that this was -3 instead of 3, if I plugged it in, I'd have x minus -3, which would give me a positive 3 here. Okay, so it does a positive. All right, so I want to identify the vertex, axis of symmetry, minimum or maximum domain and range of the function f of x equals -x plus 4 squared minus 5. So the first thing I notice is this minus sign out front, which tells me that it opens downwards. Opens downwards. Okay, there's no vertical or horizontal stretch because nothing happened. It's a -1 out front. The plus 4 tells me I move 4 units to the left, and the -5 tells me move 5 units down. The vertex, remember we said was HK, so that's going to be -4, -5, because that was in the form, the vertex is in the form y equals a, x minus h plus k. So it does open downwards. So this is a maximum. Domain is all your x values. So the domain is all real numbers. You could also say -infinity to +infinity. the range, because I stop at -5 and I'm going down, so the range is y equals -5 is -infinity to 5, including 5. Miss anything? Axis of symmetry, okay. And then the axis is y equals -5. So remember, your axis of symmetry is your k value. So axis of symmetry, k is your k value. Your vertex is comma k. Okay, so vertex -4, -5, axis of symmetry, so x equals -4. Maximum is at y equals -5. And your domain -infinity to infinity and -infinity to -5. All right, example number 3, write an equation of a parabola. So what is the equation of a quadratic function with vertex -2, 3, and a y-intercept of -1? Okay, so here's my vertex, -2, 3. Here's my y-intercept at -1. So the nice thing is I can actually write this quadratic function with the vertex that I'm given as well as the y-intercept. So I want to substitute the coordinates of the vertex for h and k. So the h value is -2 and the k value is 3. So h comma k is -2, 3. So y equals a times x minus -2 squared plus 3. Okay. When I simplify that, I get the plus 2. I substitute the values of x and y for the y-intercept. They gave me the y-intercept as 0, -1. So my x value is 0, my y value is -1. So xy equals 0, -1. So -1 equals a times 0 plus 2 squared plus 3. I'm going to subtract 3 from both sides, which gives me -4 equals a times 2 squared. 2 squared is 4, so 4a. I'm going to divide both sides by 4, so I get a equals -1. I substitute that value of a into the vertex form of a quadratic function. So a equals -1, so y equals -x plus 2 squared plus 3. So the equation of the parabola is y equals -x plus 2 squared plus 3. All right, so let's try it out. What's the equation of the parabola with a vertex y1, -4, which passes through -2, -1? So the first thing I want to do is I want to actually write out. Okay, so that is my vertex, or that is my vertex form. Okay, I know that h is 1 and k is -4, so -4. I'm going to then substitute in -2, -1 for my x and y values. When I do that, y is -1 equals a -2 minus 1 squared. Got the square up here, sorry. Minus 4. So I have -1 equals a. -2 minus 1 is -3 squared minus 4, which gives me -1 equals a. -3 times -3 is 9a minus 4. I'm going to add 4 to both sides. So that gives me 3 equals 9a. I divide both sides by 9. So I get 3/9. Apparently that's what that's going to do. I don't want to do that. equals 1/3. So A equals 1/3. Okay. From there, I can then write my equation. So y equals 1/3 x minus 1 squared minus 4. All right, example number 4, write an equation of a parabola given the graph. So the height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120, and the path of the ball includes the point 0,4. What is an expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. So they give us the vertex, they give us a point, they want us to write it in vertex, they also want us to write it in standard form, which is the ax squared plus bx plus c. That's usually the form that a lot of people see quadratic functions in. Okay? So when we're doing that, okay, so I'm going to use the vertex and the given point to write the quadratic equation in vertex form to find a. So I go ahead and do that. So y equals a times the quantity x minus h squared plus k. So h was 1 and y was 20, or k was 20. So 4 equals, that was the point they gave me, 4 equals a times 0 minus 1 squared plus 20. Okay, so that's 4 equals a. 0 minus 1 is -1. -1 squared is 1 plus 20. So I have 4 equals a plus 20. I subtract 20 from both sides. I get -16. So a equals -16. So that's my vertex. Y equals, that's my vertex form. Y equals -16 times the quantity x minus 1 squared plus 20. Now, what I want to do is I want to actually solve, basically I want to solve this equation on the right side. So I'm going to take the -16 times x minus 1 squared plus 20, and I want to factor it out. I want to distribute it. I want to get it into as simplified a form as possible. That will actually give me my standard form. So x minus 1 squared is x minus 1 times x minus 1, which gives me x squared minus 2x plus 1. I multiply each one of these times -16, and then I simplify. -16 times x squared is -16x squared. -16 times -2x gives me a positive 32x. -16 times 1 is -16, and then plus 20. When I simplify that, I get y equals -16x squared plus 32x plus 4. Okay. So I have my parabola in vertex form, and I have it in standard form. All right, so let's go ahead and try it out. I want to write the graph. The graph shows the height of the flying disc with respect to time. What is the equation of the function? Write the equation in vertex form, then write the equation in the form y equals ax squared plus bx plus c. So I have my parabola. My vertex is 210. Okay. And then my point is 0,4. So I'm going to go ahead and substitute that in for my values. So for this example, 2 equals h. So h equals 2. K equals 10. X equals 0. Y equals 4. Okay, so I have 4 equals a minus 2 squared plus, I can tell by the parabola that it's opening downward, so I know I'm going to get a negative answer. So when I actually go through this, okay, 0 minus 2 is -2. So 4 equals 4a plus 10. I subtract 10 on both sides, which gives me -6. Okay. When I divide both sides by 4, I get negative 6 over 4, which equals negative 3/2 when I simplify. So that's my A value. So y equals ax minus h squared plus k. So y equals negative 3/2 x minus 2 squared plus 10. So that's my vertex form. Then I'm going to multiply this out. So y equals negative 3/2. I have x minus 2 times x minus 2 plus 10. Oops. It gives me x squared minus 2x minus 2x plus 4 plus 10. So y equals negative 3/2 x squared minus 4x plus 4 plus 10. So then I'm going to distribute that negative 3/2. So I have negative 3/2 x squared minus 4 times negative 3/2 x plus 4 times negative 3/2 plus 10. Okay. 4 times 3 is 12 divided by 2 is 6. So this is negative 6 plus 6x minus 6 plus 10. Okay, which gives me y equals negative 3/2 x squared plus 6x plus 4. Okay. So that is my standard form, negative 3/2 x squared plus 6x plus 4, and my vertex form was y equals negative 3/2 x minus 2 squared plus 10. All right, example 5. Write an equation of a transformed function. A function g is a translation of the parent function f, 1 unit left and 3 units up. What is the equation of g? Write the quadratic equation in vertex form and in the form f of x equals ax squared plus bx plus c, or standard form. So I go from f to g. I was told 1 unit left, 3 units up. Okay, so that tells me to go left, I have to plus 1. So plus 1 and then plus 3. So f, x plus 1 plus 3. So g of x equals f times the quantity x plus 1 plus 3. So g of x equals a times x plus 1 squared plus 3. Okay. From the graph, I can see that the point 0, 4 appears to be on g. So I can use that point to find a. So 4 equals a times 0 plus 1 squared plus 3. So 4 equals a plus 3, so 1 equals a. I write that back. G of x equals x plus 1 squared plus 3. I factor this out. So x plus 1 times x plus 1 equals x squared plus 2x plus 1 plus 3. I simplify the 3 plus 1, which is 4. So in vertex form, g of x equals x plus 1 squared plus 3. You don't have to have the 1. Remember, it's automatically implied that it's there. And in the form y equals ax squared plus bx plus c, the equation is g of x equals x squared plus 2x plus 4. Okay. So what is the equation of j? Write the equation in vertex form and in the form y equals ax squared plus bx plus c. Let j be a quadratic function whose graph is a translation 2 units right and 5 units down. Okay, so I'm starting with a vertex form. So I'm going 2 units, so minus 2. And I'm going down 5 units, so minus 5. Now, what I want to do is I want to actually graph this function to see what it looks like. So if I'm still using the same parent function, I'm still going to use, okay, so I'm using the graph of f. So here's my graph, so I can see this is x minus 2 squared minus 5, because I was using this graph, which is just x squared. So if we looked at this, y equals x squared, we can see that we translated 2 to the right and down 5. So looking at this graph, it crosses at 0, negative 1. So I can use that point to solve for when I do that, negative 1 equals a 0 minus 2 squared minus 5. I have negative 1 equals a, negative 2 squared minus 5. So negative 1 equals 4a minus 5. I'm going to add 5 to both sides. So I get 4 equals 4a. So a equals 1. So my vertex form is y equals x minus 2 squared minus 5. Then I need to solve that. So y equals x minus 2 times x minus 2 minus 5. So I get x squared minus 2x minus 2x plus 4 minus 5. So y equals x squared minus 4x plus 4 minus 5. So y equals x squared minus 4x minus 1. So that's my standard form, the ax squared plus bx plus c. And my vertex form is the y equals x minus 2 squared minus 5. Okay, we can, of course, for letter B, let J be a quadratic function whose graph is a reflection of the graph of f in the x-axis, followed by a translation 1 unit down. Okay. So if I want to reflect this graph, we had to make it negative. And then I'm going to translate it 1 unit down. So this is negative x squared minus 1. Okay, one of my points is 0, negative 1, so I can use that again. That's also my vertex. So my vertex is 0, negative 1, and it opens downwards. Okay. I can use that point. I can use pretty much any point that I want. Let's find an easy one. That's not easy. Is that an easy one? Negative 1, negative 2. That's going to be my point. It doesn't have to be that point. It could be any point. 2 is going to be my point. So my formula so for this, my vertex, so h is 0, k is negative 1, x equals negative 1, y equals negative 2. So when I substitute those values in, negative 2 equals a, negative 1 minus 0, squared minus 1. So negative 2 equals a, negative 1 minus 0 is still negative 1 squared minus 1. So negative 2 equals a minus 1. I'm going to add 1 to both sides, so negative 1 equals a. So the vertex form is y equals negative x squared minus 1. Technically x minus 0. You want to put it in vertex form. Okay, when I multiply this out, I get y equals negative x squared minus 1, and that's my standard form. The ax squared plus bx plus c. There's no bx in this example. So the equation is j of x equals negative x squared minus 1. Okay. So concept summary, vertex form of a quadratic function. The graph of a quadratic function is called a parabola. A quadratic function can be represented by an equation in vertex form, y equals a times x minus h squared plus k. Vertex form shows the different ways in which the graph of the parent function f of x equals x squared can be transformed. So we can look at graphs, we can look at numbers, and we can look at the algebraic way in which we do this.